So today we're going to look at 29 and 30. For 29, we're going to go back and explain conditioning, operant and classical conditioning from not just an environmental stance, but also a cognitive and biological perspective. So when we look at cognition and biological predispositions, we have the biological perspective, right? So we are predisposed to learn things that affect our survival. Early behavioralists like Pavlov, Skinner, Kimball believed that really any behavior was capable of being conditioned as long as the organism was capable, right? So we find, though, that however this isn't the case, that the environment isn't entirely responsible for our conditioning and our behavior and our learning, but also there are other factors, as we see in the biopsychosocial approach, right, that we discussed in Unit 1, in which our learning is the result of, yes, environmental, social, cultural influences, but also psychological influences, cognition, and biological predispositions and influences on our behavior, like taste aversion, which we'll look at. We are predisposed to avoid threats through our evolutionary ancestors that they may have faced, and this includes all of these three approaches. So when we look at the biological perspective, one of the first discoveries, or really important discoveries, is Garcia and Colling's experiment on radiation. And so what they discovered was that taste aversion illustrates a classically conditioned dislike or avoidance of a particular food or drink that develops after an organism becomes ill from eating or drinking something. So in this case, the rats are learning to make a certain biological association over other environmental associations. In this case, flavored water became really the only conditioned stimulus that produced the conditioned response of nausea. It wasn't lights or sounds that were also presented with the conditioned stimulus that caused that conditioned response. It was the flavor of the water. Above, you have the taste as the conditioned stimulus, the radiation as the unconditioned stimulus, and the nausea as the conditioned response, right? Or the unconditioned response, because radiation will cause nausea. So if we look at Garcia's experiment, first he takes an unconditioned stimulus, and again in this case it's the radiation, and this is produces an unconditioned response. It produces sickness, right? And so next Garcia takes different neutral stimuluses, okay, and some of those would be the flavored water, obviously. He also takes water. He uses lights, flashing lights, for sight, and he uses auditory stimuluses like sounds that relate to the radiation. Now, the conditioned stimulus, the flavored water, was the only conditioned stimulus of the three that really produced this effective learning, this conditioned response of nausea, regardless of whether or not the radiation was in the water. Even after the fact, it learned that flavor of water was associated with radiation, therefore leading to a conditioned response, sickness, nausea. So the sights and the sounds remained neutral to the rat's learning of this conditioned stimulus. And so the significance in all of this is that taste aversion has an evolutionary purpose in which rats need to avoid certain foods that taste bad because it could lead to harm for them. It could lead to sickness. It could lead to death. It could lead to illness. And so, yes, environmental things like sights and sounds do influence us. In this case, however, they didn't influence the rat's association of the nausea. And so Garcia demonstrated in his research that biology also impacts and is important to our conditioned learning. It's not just lights and tones. Yeah, so for instance, let's say that my mother cooks a soup for me, right? And in this soup there's chicken. However, in that chicken there is salmonella. Okay? Chicken's bad. it wasn't cooked fully, and I eat it, I'm eventually going to make an association later, 4 hours when I'm in the bathroom on the toilet, because I have now been influenced by salmonella, which is really nasty, a really nasty bacteria that you definitely want to avoid from poultry. And I'm going to make an association with that soup, probably the taste of that soup. So next time I see that soup, I'm going to avoid it. Right? I'm not going to want anything to do with chicken noodle soup. Now, if that happens, right? If I get salmonella poisoning from this chicken noodle soup, I'm not going to make that association with the kitchen. So every time I see a kitchen, I become nauseated. I'm probably not going to make that association, and I'm certainly not going to make that association about my mother. I'm not going to become nauseated every time I see my mother because of the chicken noodle soup poisoning, the food poisoning, right? I'm going to make that association with the taste of that soup. So this just is another example of taste aversion and how I'm able to associate my learning and make a connection about what it was that actually made me sick. And it helps me avoid that in the future from an evolutionary standpoint. Okay, so go ahead, pause the video for a minute, answer this question, apply your understanding of taste aversion, go ahead and label the UCS, the UCR, the CS, and the CR, and think of an example, a unique example of taste aversion in your life, something that a time this has happened to you. So go ahead, pause it, and answer the question. Okay? All right, hopefully you paused the video and you did that activity. All right, let's look at Robert Rescorla and his findings on the cognitive processes of classical conditioning. So Pavlov believed that all you need to do is pair a neutral stimulus with an unconditioned stimulus, and boom, you got conditioning. It occurs. But Robert Rescorla, about 100 years later in the 1970s, argued this, basically stated that, hey, I think there are cognitive and mental aspects related to our perceptions and our learning and associations as well. So his argument was that the neutral stimulus cannot become a conditioned stimulus unless there is what's called a predictive value, right? There needs to be a reliable predictor to be able to determine whether or not that CS and that UCS are associated with one another. An example of this would be of predictability would be if a shock always follows a tone, right? Let's say I touch a button and the shock always follows that tone. And then sometimes a light occurs after the tone. All right. The rat is not going to associate that light with the shock. It's going to associate the tone with the shock because the tone occurs every single time before that shock occurs. So if the flash of light occurs sometimes, it's not as predictable. It's not a reliable predictor of what's going to happen. So fear is going to instill in that rat's mind when it hears the tone versus when it hears the light, because it's a more valid, predictable stimulus than per se the light. What did Rescorla and Wagner show in their discoveries? Well, they showed that an animal can learn the predictability of an event. And the more predictable something is, the stronger the association will be made with that conditioned response. It demonstrates that cognition and what happens between our ears is very important. And expectancy and predictability are a cognitive process in conditioning. Right? So if you go way back and you look at Pavlov and classical conditioning, why did the bell work? Why did that bell work when the dog salivated to the tone? Why did he salivate to the tone? Why didn't he salivate to other stimuluses in the room? And these are good questions that a scientist needs to ask, right? If he's not asking these questions, well, was he responding to his tail wagging? Was it operant conditioning? Right, when the dog wagged its tail, and then he received food. Did the dog make that association? Did the dog make an association of when Pavlov was in the room? That's when the dog received food. When Pavlov itched his left elbow, that meant that the dog was going to receive food. Right? There's so many different pieces of stimuli that the dog could possibly associate that conditioned stimulus with the unconditioned stimulus. And so what we know through Rescorla's research is that the reason why the tone was the most predictive stimulus in this conditioning process was because it was the most reliable, right? Every time that tone played, food was presented, the unconditioned stimulus was presented. And so it was most salient, I guess that's what I'm trying to say. It was the most salient stimulus in the room. It was the most noticeable, the tone, right? Versus the other conditioned stimuluses. So the dog didn't associate the food with all the other pieces of stimuli in the room, but only the tone.